This next question is really something. Matthew Gordon of Greenville, Florida writes, Dear Newton's Apple, I heard that Voyager 2 saw 8 moons around the planet Neptune. Our textbooks say that Neptune only has 2 moons. So I got a question wrong on a test. Could you settle this question? The other kids in my class think I'm nuts. Well, Matthew, since the 2 Voyager spacecraft traveled to the outer planets, they have virtually rewritten the astronomy books. But our field reporter, Peggy Knapp, is still kind of attached to her old high school textbook. So to find out what's new in the solar system, we sent Peggy and her book to Voyager's Command Center, the Jet Propulsion Lab in Pasadena, California.
Hello.
Hi.
Hi, I'm Peggy Knapp from Newton's Apple.
Oh, good. Please sign in.
Okay.
You know, that book is out of date.
Well, it's a little out of date, but it's not that old. I just used it in high school. It's not that old. Oh, it's not that old.
Out of date? I happen to know that when Voyagers 1 and 2 blasted off in 1977, this textbook was just fine. What makes Voyager so special anyway? One guy I knew had the answer was Voyager science team member Randy Wesson.
Randy, hi.
Hi, Peggy. How you doing?
Good.
Oh, that book's really out of date.
I've heard that. Thank you. So this is Voyager, huh?
This is the engineering model.
But the real Voyager is bigger than this.
No, this is the exact size. This is what we use to build the spacecraft. It's our model.
Obsolete by today's standards, Voyager's equipment is still working. Its energy is provided by a small nuclear power supply, generating only 450 watts. That's enough power to run 11 scientific instruments, which measure and record everything from cosmic rays to magnetic fields to pictures. Voyager sent back thousands of beautiful images never seen before.
Now let's talk about some of the data that you're collecting. What, like photography? How do you take a picture of a planet?
Well, what you do is you have to know where your target is, the planet, and you have to know where the spacecraft is. And you have to know in advance where those things are going to be.
Why?
Well, it just takes so long to communicate with the spacecraft. To send a command to the spacecraft takes more than 4 hours to get up there. So you have to say, okay, in advance where everything is going to be, and then tell Voyager to look in that direction, and hopefully the object will be in its field of view and take the picture.
Drifting past the planets and moons, Voyager responded to commands from Earth, moving its camera platform to find its subjects. Voyager then encoded the information and sent it back to Earth with its high-gain antenna.
That antenna, when we're using high power, is 23 watts of power. That power is the amount of power it takes to run a light bulb in your refrigerator.
And what do the antennas on Earth hear?
Well, that's the interesting part. If you took that refrigerator with that light bulb and you moved it out to Neptune, 3 billion miles away, the amount of power that these antennas on the Earth are picking up is about 1/10 millionth of 1 millionth of 1 watt. And we put everything together with that.
And you can hear that?
Sure can.
And to make sure they could hear that tiny whisper, JPL scientists rounded up more ears. All over the world, radio telescopes like the Very Large Array in New Mexico joined Voyager's network to pull in signals from 3 billion miles away.
How far did Voyager actually travel? Well, let's try and put it into some sort of perspective we can understand. Say, for instance, the sun is this grapefruit. Earth would be 45 feet away, the size of the head of a pin. Jupiter would be 250 feet away, the size of a marble. And Neptune is 1,500 feet away, a third of a mile, and only the size of a pea. Now, given this scale, Voyager is racing along at about the same speed at which grass grows, and the nearest star is in Cleveland.
Which is enough to give you a headache if you really think about it. But where did Voyager get the energy to go that far?
What we did is we sent it to Jupiter, and then we used the gravity of Jupiter to bend it on its way and accelerate it to the other planets.
And how does that work?
Well, that concept is called a gravity assist. And the best way to think of it is you have a planet with a certain amount of gravity. If you go very fast by an object, but far away, you'll just go in a straight line. If you go a little bit closer, you get bent around the object. Well, by judging how close you come to the planet, you can get the right amount of bending to go to the next object.
The 2 Voyager spacecraft actually stole some of the planet's motion, which, like a slingshot, sped them on to the next target. Voyager 1's path through the moons of Saturn took it out of the hunt, but Voyager 2 made it all the way to Uranus and Neptune. So what did they see out there that had changed my book? Imaging team scientist Rich Terrell had the answers.
Okay, everybody in this place is telling me I need a new textbook. Why do I need a new textbook?
Probably because everything in it associated with the outer planets has been changed because of Voyager.
Everything?
Just about everything. Voyager visited Jupiter, Saturn, Uranus, and Neptune and has essentially rewritten all the textbooks about it.
Oh, well, why don't we start with Jupiter and I'll take notes.
Okay.
Rich then took me on Voyager's grand tour, starting with Jupiter, the largest planet. These beautiful patterns on Jupiter's outer surface are actually violent storms. Voyager confirmed that the Great Red Spot is a giant anticyclonic storm. It swallows up smaller storms and seems to stabilize the atmosphere. Voyager also took beautiful pictures of Jupiter's moons. And as Voyager 1 passed the moon Io, an amazing thing happened. A volcano erupted on its surface, spitting sulfuric ash hundreds of miles into space. Voyager 2 passed Io just 4 months later, and the moon's surface had changed.
If you lived on Io and you'd wake up in the morning, you'd turn on your radio, you wouldn't get a weather report because there's no air. What you would get is a geology report. You might have mountains building to the east and volcanoes erupting to the west. It's a really, really strange place, far exceeding even the imagination of science fiction authors. We also discovered a ring around Jupiter.
Rings?
In fact, there's rings around Jupiter, Saturn, Uranus, and Neptune, and each planet has a different, unique kind of ring system.
And sure enough, as Voyager swung around the dark side of Jupiter, there, backlit by the sun, was a ring, something many scientists said would not be there. And speaking of rings, Voyager's next target was Saturn.
The most interesting thing about Saturn that we knew before we got there were the rings. And
Right, I've got rings.
And I think the spectacular thing about the rings when we got there, we found that the rings were not comprised of 3 or 4 different kinds of areas, but really thousands of features. In fact, the features were so different that when we took 2 different pictures taken a short time apart, the features didn't match up. So like ripples in a pond, the features on Saturn's rings constantly move, constantly change.
After Saturn, it took Voyager 2 5 years to get to Uranus. The planet Uranus looks like a fuzzy blue tennis ball and for some reason rotates on its side. Voyager found 15 moons around Uranus, which is 10 more than we knew about, and shot close-up views of Miranda, a moon that looks like a messed up jigsaw puzzle.
What happened?
Something tore up the world.
Somebody dropped it.
Well, we think that sometime after it had collected enough material to form a moon, it was impacted by something very large, and this probably broke up the planet, and it recollected into big chunks. And as these chunks kind of settled back into a round planet, it locally heated up certain portions of it, so you get this very, very peculiar terrain forming on it. It's something that was very unique. We hadn't seen anything like that anywhere else.
How about Neptune?
Neptune was a really pleasant surprise for us. We were worried because the further we went out, the more difficult it was to see detail in the clouds. It turned out that Neptune had a very clear atmosphere, and we were able to see down very, very deep and see a great deal of structure.
Neptune is a beautiful blue planet with violent weather. Voyager found giant storms, a strange clumpy ring system, and 6 new moons. But Voyager's grand finale was Neptune's largest moon, Triton.
Here's a moon that had a great deal of variety on its surface. We had wind streak patterns, we had an atmosphere, so there was weather, there was geology. We found erupting geyser-like volcanoes on the surface, leaving these plumes in the atmosphere. It was a really very, very exciting world to see.
Besides the fact that I need a new book, what does all this mean?
Studying the planets in our own solar system answers one of the fundamental questions in planetary science, and that is, what is the nature of our world, and are we unique? And the way we go about answering this is to understand the processes that formed our planet. How did we originate? How did life form on Earth? The exciting thing that we're finding is that the processes that formed the Earth seem to be understandable and seem to be common, both in our own solar system and around other stars. And what's more, the raw materials that formed life on Earth appear to be natural ingredients that are common throughout the solar system.
So given the chance that intelligent life does exist in the galaxy, a phonograph record was created and attached to both Voyager spacecraft. Encoded on the record are greetings in many languages, music from many cultures, and photographs showing who we are. Voyagers 1 and 2 are leaving our solar system, and millions of years after we're gone, they'll continue traveling as our ambassadors. out past the stars.